Welcome to my algebra class. We're on chapter 12, section 2. We're going to be working with another method of solving a quadratic, which is called completing the square. In 12.1, the equations were, we had perfect square trinomials. If the quadratic equation is not a perfect square trinomial, we can make it one. In a perfect square trinomial, notice that the middle term is twice the product of the square roots of the first and last terms. So I could work backwards, and to make it a perfect square trinomial, move over anything that's not a perfect square, any number, because our problem is right here, and then take half of the middle term, the coefficient, and square it, and I've made my perfect square trinomial. So we'll do that to this one. The 18 is not a perfect square. Remember, we have to end with a perfect square. So I'm going to move it to the other side by adding 18. Then I'm going to take half of the 4, which is 2, and it doesn't matter if it's positive or negative because you're going to square it. So half of 4 is 2, square it, I get 4. And I added it to this side, and I have to remember to add it this side, otherwise I've changed my equation, unbalanced it. So be sure you add it to both sides. So now I have a perfect square trinomial. The square root of x squared is x. The square root of 4 is 2. There's a minus here for the middle term, so I have to put a minus here and square it. And 18 plus 4 is 22. So now I can take the square root of this side and the square root of this side. And I get x minus 2 equals plus or minus the square root of 22. Add 2 to both sides, so x equals 2 plus or minus the square root of 22. And I always have to simplify my radical, but there's nothing I can do with that. So there's my answer. 2 plus the square root of 22, and 2 minus the square root of 22. Okay, we'll do enough of the evens. Hopefully you catch on to what we're doing here. So you need a sheet of notebook paper, headed. Title is page 566, numbers 1 to 12. Problem number 2. It says solve by completing the square. Give irrational roots in simplest radical form, and then approximate them to the nearest tenth. So we're going to need our calculators. So problem number 2. See if I can make this just a hair bigger. Here. We have y squared plus 8y equals 10. So we want to complete the square, make this a perfect square trinomial. We take half of the 8, which is 4. You don't have to show this. And then we square it. And add it to this side, and add it to this side to balance our equation. So now we have a perfect square trinomial. Square root of y squared is y, and the square root of 16 is 4. This is positive, so this has to be positive. Squared equals 26. Now we can take the square root of both sides, and we get y plus 4 equals plus or minus the square root of 26. Subtract 4 from both sides, we get y equals negative 4 plus or minus the square root of 26. So that's one answer, and then they also want us to give the answer to the nearest tenth. So negative 4 plus the square root of 26 is going to be 1.1 to the nearest tenth. and negative 4 minus the square root of 26 is negative 9.1 to the nearest 10th. So we need both of those, and we need this. Problem number 4, we have c squared plus 18c minus 175 equals 0. Well, 175, negative 175 is not a perfect square, so we're going to have to add 175 to both sides and get rid of it. So I'm going to move it to the other side by adding it. And then complete the square. I take half of 18, which is 9, and then square it. So I'm going to add 81 to both sides. So now I have a perfect square trinomial. The square root of c squared is c. The square root of 81 is 9, and it's plus between them. And 175 plus 81 is 256. So take the square root of both sides. So I get c plus 9 equals plus or minus the square root of 256. And I believe 256 is a perfect square. It is. So that equals plus or minus 16. So our solution to the equation is 9 plus 16 and 9 minus 16. 9 plus 16 is 25, and 9 minus 16 is negative 7. I made a mistake here. I'll have to correct it. When I move that 9 to the other side, it should have been negative 9 plus or minus 16. So that's negative 9. I have to subtract 9. I didn't. Minus 16 and negative 9 plus 16. So that gives me negative 25 and 7. So be careful, it's easy to make mistakes. Number 6, we have z squared minus 6z minus 307 equals 8. Well, negative 307 is not a perfect square, so I need to remove it from this side. I can do that by adding 307 to the other side, to both sides actually. So now I have z squared minus 6z equals 315. So now I take half of the negative 6, and I don't care about the sign, so half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides. This is a perfect square trinomial. The square root of z squared is z. The square root of 9 is 3. And there's a negative sign for the outer and inner terms, so that should be negative 3 squared. And 315 plus 9 is 324. So I take the square root of both sides. And I get z minus 3 equals plus or minus the square root of 324. Let's check and see if that's a perfect square. Whoops, I gotta clear it. It is, it's 18. So equals plus or minus 18. So z equals, add 3 to both sides, 3 plus or minus 18. So 3 plus 18 is 21, and 3 minus 18 is negative 15. Problem number 8, we have 2b squared plus 16b equals 4. Well, I have two problems. Right away, I can't have 2 in front of b squared because this has to be a perfect square. So the first thing I'm going to have to do is get rid of that 2. So I'm going to divide everything by 2. So I no longer have a number in front of b squared. So b squared plus 8b equals 2. Now I can complete the square. I take half of 8, which is 4, and square it, and 16. So I add 16 to both sides. This is a perfect square trinomial now. So the square root of b squared is b. The square root of 18 is 4. The middle is plus. And 2 plus 16 is 18. Now I can take the square root of both sides, and I get b plus 4 equals plus or minus, and we'll simplify this. This is 9 times 2, so I can take the square root of 9, which is 3, and I still have the 2 underneath, so it's plus or minus 3 radical 2. Now I subtract 4 from both sides to get rid of the 4 here, so that's negative 4 plus or minus 3 radical 2. So on my calculator, I take negative 4 plus 3 radical 2, and that equals 3, and then times. Okay, there's something wrong here. Let's try it again. Negative 4, negative 4 plus 3 times radical 2. And I get 0.2 to the nearest tenth. And then negative 4 minus 3 radical 2. So clear that. Negative 4 minus 3 times radical 2. And I get negative 8.2. Be sure you can do those on the calculator. So here are my answers. Problem number 10. I have w squared plus w equals 3. And now you'll see why this method is not used when the middle term here has a coefficient that's not even. So the number in front of w is 1. So I take half of 1, which is 1/2, and I square it. So I get 1/4. So I add 1/4 to both sides. So the square root of w squared is w, and the square root of 1/4 is 1/2, and it's plus. And this is 3 plus 1/4, so that's, if we change that into a fraction, 3 plus 1/4, that's 3 1/4, which is 13/4. So we'll use 13/4 here. Take the square root of both sides, and we get w plus 1/2 equals plus or minus the square root of 13/4, which is square root of 13 over 2, because the square root of 4 is 2. So then get w by itself by subtracting 1/2. We get w equals negative 1/2 plus or minus the square root of 13 over 2. So doing the first, then I can add them together. since they have the same denominator. It's negative 1 plus radical 13 over 2, and that's negative 1 minus radical 13 over 2. So that's our final answer right here. And now to approximate to the nearest tenth and get our last part. So we take parentheses, clear it first, parentheses, negative 1, parentheses, negative 1, let's clear it again, parentheses, negative 1 plus the square root of 13, parentheses, divided by 2. And we get 1.3, which is correct. So writing 1.3 down for this one. And then again with your calculator, make sure you can do this. Clear this out. Parentheses, negative 1 minus the square root of 13, parentheses, divided by 2. And that comes out negative 2.3, which is correct. So we have it in rational form with radicals, and then we have it to the nearest tenth. And the last problem, number 12, we have c squared minus 7c minus 2 equals 4. Okay, the first thing to do is move the 2 over. So c squared minus 7c equals 4 plus 2. So now we have c squared minus 7c equals 6. Now we have to get a perfect square trinomial, so we take 7, take half of 7, which is 7 halves, and square it. So that's going to be 49/4 that we're going to add to both sides. So we get square root of c squared is c, and the square root of 49/4 is 7 halves, and it's minus. And 6 is 24/4 plus 49/4 if we put that over 1. So that gives us 73/4. So we take the square root of both sides, and we get c minus 7 halves equals plus or minus the square root of 73 and over 4, and the square root of 4 is 2, so we can just leave that as 2. Solve for c, we're going to add 7 halves to both sides, so that gives us 7 halves plus the square root of 73 over 2, and 7 halves minus the square root of 73 over 2. Since they both have the same denominator, we want to write it as one fraction, so 7 plus radical 73 over 2, and 7 minus radical 73 over 2. So that's one part of our answer. Now we're going to approximate our answer to the nearest tenth. So parentheses, clear, parentheses, 7 plus the square root of 73, parentheses, divided by 2, gives me 7.8 to the nearest tenth. We need to round, there's a 7 after that. And then the second possible answer, remember, is squared, so we have 2. Clear, parentheses, 7 minus the square root of 73, parentheses, divided by 2. And the other one is 0.7. Excuse me, 0.8. Should be negative. Let's try that again. Parentheses, 7 minus The square root is 73, parentheses, divided by 2. Well, it should be negative. I don't know why it's not doing that. So it's negative 7.8. Negative 0.8. There we go. And that concludes the evens. Be sure you check the answers in the back. Get help as you need it.